we are in 3-4. This is normal distribution still, but this is one of the things that the calculator does nicely. So let's say we have our normal distribution, but we want to figure out what region this would be between. And let's say these are not between, let's say this is like negative 1.4 standard deviations to negative 1.8 standard deviations. All you're doing with standard deviations when you're talking about normal distribution, you're talking about the percent of the area under the curve, where 100% of the area underneath the curve is where we're at. This would be far less than 100% of the area. Okay, this might be an area of, it'll give it to you as like 0.13, which is 13% of the area or something like that. Okay, does that make sense? All right, so the calculator does some nice stuff. Now, excuse me. It depends which calculator you have, and I don't know which version I have right now. So there's something on the calculator that says the Normalcdf, okay? And it's just normal, meaning normal distribution. CDF, you're trying to find about some area. So some information just to know, if we had, this is a left boundary, and this is a right boundary, okay? And if we were trying to find what that area is. So the calculator is going to calculate it. Back in the olden days, you actually had a table, these huge tables of values in the back of your stats book that you'd have to look at, and you'd have to find between the two, and then you say, okay, this is how much area we're talking about. The fortunate thing for y'all is we do have now available for people information. So example 1 says, what percentage of the bell curve is between, and I'll just write this up, we have a z-score of negative 0.75 and a z-score of positive 0.25. So if you think about what that really is looking like, if this is one standard deviation below, this is one standard deviation above, 0.75 would be about here, and then 0.25 might be about here. Okay, so you're trying to figure out what this area is between the curve. So I'm going to hopefully hop over and make this work on the calculator. We'll see. All right, so on the graphing calculator, I have the screen up there. Excuse me. So where are we going to find this? Our graphing calculator can calculate this percentage. It takes calculus to work with math by hand. We're not going to do calculus. Under the second distribution menu. So second distribution, where are we at? I'm just trying to look on my calculator where that falls. Oh, there it is. Second vars goes to distribution. And then you're going to look for Normalcdf, okay, which is the number 2 spot. Okay, so this calculator is going to allow it to be plugged in. So we want to find between negative 0.75 and we want to go up to positive 0.25. Okay. Left boundary, right boundary. We are going to, let's see. Normalcdf that gives you the percentage normal distribution of any two z-scores, which we'll call the left boundary or right boundary. The calculator commands while assuming the z-score mean of 0, meaning we're not really concerned about what our average is because it's all going to be the same. Yeah.
Oh, I was just going to say the z-score meaning the same as the regular.
So yes and no. What you kind of have to look at on this is you have to realize the very center, the mean on a normal distribution that isn't from a problem is 0. Okay? So we're going to call it 0 because that's just right in the middle. And if we go to the right, it's positive up to 3 or 4, and it's negative down to negative 3 or negative 4.
So should we always assume that it's 0?
Yeah, the main thing you're looking for is normal distribution is part of it. And they might say, hey, you have this and this and this. I think for the most part you can, at this point, not worry about it. So we're just going to say that the mean is 0 because we're talking about the middle. and we're talking about 1 standard deviation. So if you go in here and hit that, so you have lower boundary, upper boundary, so furthest to the left, furthest to the right, then it gives you something like this. Now, on some of the calculators, mine allows you to do this, but some of the older calculators, it'll come up with Normalcdf, where you have to do lower boundary, comma, upper boundary, comma, mean, comma, standard deviation, close parenthesis. Okay, so that's basically what that means. So if I do this and I hit enter, right there, you're talking about if you are from negative 0.75 as the z-score, so negative 0.75 distributions to the left, all the way up to 0.25 standard deviations to the right, you're talking about an area of that region is 0.37%, or 37% of the area under the curve falls between negative 0.75 and negative 0.25. Okay? Cool. And we got the same answer that's in the book, which is always a plus in Stirrups class. And then it says, what if we want to know the percentage of normal distribution greater than a z-score of 0.75? So let's go back to our screen. The next one says, we want to know if we are greater than 0.75. So we're talking about this as far as our normal distribution. If this is 0 and this is 1, 0.75 might take place about here. So you're talking about that area there, okay, as it goes all the way out. Okay, so there's one of two things we could do. We could take 100% or 1 and subtract whatever this area is, because normally it's finding everything to the left. Okay, if you subtract it, then it would give you what the area is to the right. But I think the calculator is going to take care of it for you pretty nicely. Okay, so if we want to know the percentage of normal distribution greater than a z-score of positive 0.75, we have to use the other. What do we use for the other boundary? The answer is infinity, but we don't have infinity on our calculator. But our calculator doesn't have an infinity button, so we have to use a really big number. So what they're going to do on the calculator is this. Okay, again, I want the area to the right. So we'll go back to the calculator. I'm going to go second distribution, number 2. My lower bound is going to be 0.75. And then my upper bound, we're going to make huge. Okay? Huge number, right? Okay? And then we should be able to just hit paste at this point.
So it doesn't matter what the number is specifically, it just has to be a really big number.
Big number. Yeah, like more than 10,000 probably.
And we should just leave it as a 1 in the first value.
Yeah, the first value we're just using as our left bound because we wanted values bigger than positive 0.75.
Sorry, I meant on the really big numbers. We should just leave it as 1 in the first place.
Yeah, that's still the standard deviation. So what we're doing on this was my left bound. This is going to be my right bound, which is like a ridiculous amount of standard deviations to the right. But in theory, our bell curve doesn't touch the x-axis ever. It's an asymptote. So it doesn't matter how big of a number. I mean, I imagine that there's going to be someone in here that's like going to put 55,000 zeros in there, and it's probably going to get an error on the calculator because they went a little bit beyond. But you're talking big. Yeah.
On the homework, it asks us to draw a bell curve for every problem. Do we have to do that?
So, I mean, honestly, I'm drawing a bell curve each time with these. So when it says, you know, hey, we want something between left and right, this is basically what I'm looking for. I maybe label this, you know, hey, this is negative 1.23, and this is 1.77. Those are just the standard deviations. That right there is totally fine in my opinion. Okay. Now, yes, we do realize that if we have 0 here, we'd have a 1 here, we'd have a 2 here, we'd have a 3 here, and that's talking about the standard deviations. We'd have a negative 1 here, negative 2 here, and a negative 3 out here. Okay. I mean, to me, drawing just the green, not worrying about the red, as long as y'all can see the difference between the green and the red, you should be totally fine with that. You're just kind of describing what's taking place. Okay, so that last one came at 22.7. I think that was the answer I got on mine as well. Go here. Yeah, 22.7. Good. Get the same answer. What if we want to know the percentage of normal distribution that is less than a certain z-score? We need to find a very small number to represent. So what is the percent of the bell curve less than 0.43? So again, we're going to go back in normal distribution, CDF. So my lower value we're going to have as a really small negative number, okay? And then they were talking about positive 1.43, so you just plug that in. So, I mean, it looks kind of silly you're dealing with something like that. You're talking about something that's obscurely to the left. Again, we can keep our stuff in there. Hit paste. Boom. Hit enter. So if you had a z-score of 1.43, that means that 92.4% of the area is to the left. That means that if you were on any standard normal distribution curve, ACT, SAT, AP scores, anything like that, if you scored 1.43 as a z-score or 1.43 above the standard deviation, that means you did better than 92.4% of the other people that took the test. Okay, so that kind of means something. And again, we talked about in school, in your different colleges where they have certain scores that are cutoff values because they realize the further you go to the right, the higher percentage you did better than the majority of people. Okay. It's often important to illustrate these percentages with a sketch of a bell curve. The region calculated, for instance, the following could be used in this example. So they have that example. It looks like they tried to shade a region, didn't come out. You just want to see, is it relatively reasonable to talk about what that was? So this one talked about a huge z-score. Okay, so let's go back here. Whoops, I want to go back here. I want to switch. So that normal distribution, we have 0 here and we have 1 here. And we were talking about 1.43, so you have 2 here. So that 1.43 is like right here. So does this amount of area here in the blue, can you account that for, does this seem like it could be pretty close to 94 or 92.4% of the area under the curve? I mean, this tail here is getting pretty small. And then when you refer back to it, you know, if you go back to the rule that we had, that was the, you know, think of what a normal distribution would look like. So within one standard deviation, you're talking about 68% of your data. And then as I go out, this is 13.5%, you know, 2.5%. And then way out here is 0.15%. And then same thing over here. This is 13.5% here. Down here, we are at 2.5%. And then way over here is 0.15%. So does it seem reasonable that if we had that z-score on here where we had 0, 1, 2, if we were talking about 1.43, you're talking about this region right here. So that region here is a portion of the 13.5%. And then you're talking about, you know, would that 68%, there's a 0.5 right there, plus this 13.5%, plus the 2.5%, plus the 0.15%, plus the portion of 13.5%, the portion here, okay, does that seem reasonable that you're talking about 92.4% if your z-score was at positive 1.43? And I think so. I mean, if we go 68 plus 13 gets us up to 81.5, a little bit more than 81.5, you get to 81, 84, you get up to 84.15, and then, so just this region alone here is greater than 84% of the area. So do we think that this area here could account for another roughly 8% or 7.4%? I think so. I mean, that region's 13.5%. We're at 1.45. So we are, when you talk about, if you just kind of zoom in on that little area, we have our normal curve. So if we're talking about this area here, that is at 13.5%. And if this is 1 and this is 2 as far as standard deviations, we get to 1.43. You're talking about right here. Okay? Does this blue area here seem like it could be, and granted I wrote it by hand, does it seem like it could be about half or more of the area? I mean, we're talking about like a sliver. You're talking about a sliver. If this is 1, this is 2, this is 1.5. You're talking about a sliver of it right here. So does that green region right there, does that seem like a larger area region than this black region here, just by visual? I think so. Okay, and again, I didn't draw it perfect. I mean, there's simulators that we can use that can do stuff pretty uniquely. There's one thing I want to try, and I don't know if my calculator is going to do it, but I know that there's some place on here. Let's see. Just trying to think. Y equals calculate. Just trying to remember. I remember there was a way that you could do a graph on here. I just want to Google something. I remember I saw this a while ago, and I don't remember which calculator it is. Area, let's see. Normal CDF TI-84 graph. Let's see if there's any. What did I do? What did I do wrong? Oh. I've done that before.
No, for real. The only thing that I like about him is his outfit. And that's only like halfway throughout the week.
There's like no time to do anything. Well, it's just like how are people gonna make us do an entire test from other people's.
There we go.
From other people's presentations.
That's what I want to do. Shade.
Good job, Mr. Stirrup.
I think this is it. Shade norm.
No, I didn't.
All right. Oh, boo-hoo. You got fluid in your lungs. Cry about it.
I'm just drowning in air.
All right. So on my, I'm going back to the first example where it was negative 0.75 to 0.25. I think this should work. All right. Come on. All right. All right. Then let's do second. All right. Let's go to Zoom. Let's go to Zoom. Let's go to. Yeah, let's go to window.
Yeah, but
So
what are you gonna
threatening?
do? Once you take it, no.
Say, well, you're gonna have to take a 0 or whatever you get. And then that's when I'm gonna take it and throw. I swear, I'm gonna. Let him take. I'm serious. I'm so serious. You'll regret it.
Try this one more time. Second, distribute, draw, shade normal. Negative 0.75. You guys don't laugh at my jokes.
Yeah, but your jokes are actually funny.
But you don't laugh.
Like when I laugh at sociology jokes, I'm like the only one laughing. Because it's not funny.
I'm not joking.
You're
I'm
funny.
like, I really hope it's right. I don't know. I don't know. Like I'll love.
There we go.
No, I don't know.
All right. So,
I was gonna make us research.
I got lucky. So that very first problem we did that said, hey, we want to know what the area is at a z-score of negative 0.75 to positive 0.25. And they said that the total area was 37.2. So there's my area, there's my lower z-score, there's my upper. That shaded region, what you have to do is you have to make sure you change the window on your calculator. Okay? You want to go basically in the x or the y direction from negative 10 to positive 10. As far as the y in the y direction, the normal curve is not going to exist in the negative region. So down in regions 3 and 4. So you make your minimum y value 0, and maybe you make your maximum 1 or 2 or 10 or whatever. But it'll draw your normal distribution. So that's a nice visual representation of the very first problem we did.
How do you get the actual curve?
All right, so first thing you're going to do is you're going to go in your change your window. I did mine from negative 5 to positive 5. My y minimum 0, my y maximum 1. So that's my first thing you have to trick the calculator to do. And then you're going to go back in, you're going to go second, distribute. And rather than do a distribution, we're going to draw and our shade our normal distribution. So if I did the one that we wanted a value that was greater than 0.75, and then you do the upper limit that's big, we'll just do 100. Let's see if this even works. It's thinking about it, it's going to redraw it. I think it's going to redraw it. Oh. So there's the area bigger than the 100. Yeah, that looks kind of fun. I don't know why it has both areas there. Maybe I have to clear the one. So, I don't know. There's just different things that the calculator is going to do for you to have fun with. So it says, be careful, don't trust any percentage calculator with the normal CDF if the data is not actually known to be normally distributed. Normal distribution percentages simply do not apply in any other shape distribution. So friends, the main thing you're looking at when you're working on a problem, if they give you some data and they say it's normally distributed, that means it's normal distribution. That means your normal CDF is going to work. You find that normal CDF under second, distribute. You could try and draw it if you want, or you can just do the number 2 on it. Lower bound, upper bound, standard deviation, or mean of 0, standard deviation of 1. And so that's doing normal distribution. So I think that is plenty for you all to have the opportunity to look at homework 3-4, 191 to 192. Okay? And we'll talk about that tomorrow. Again, if you need to make up the quizzes with me that we missed last time, make sure you come see me. Let's get it done sometime this week if you could on one of your off periods. And if you come in, if you're like Aaron, you got to come in during one of my freshman classes, especially my 3rd period. There are some kids in there that just do not know how to behave.
Hold on, wait. Who was the high group and who was the low group?
Who is the?
Did Hootsie?
The two were high, and then the